Okay, so another thing that'll help make it easier and for factoring, not only make it easier but also be essential, is the special patterns. Okay, if you factor certain types of trinomials, you'll notice that you get the same thing every single time. Now, the most essential of these is, and that I really, out of all these that I want you to know, absolutely for sure, is the difference of two squares. And a difference of two squares is simply that. A difference, meaning subtraction, of two squares. So the first term is a square, and a second term is a square. So a squared and b squared. When you factor that, it's always going to be the same thing. A plus b times a minus b. It's always going to work out that way. So for example, if I had x squared minus 4, we'd say, okay, was the first term a perfect square? Yes. Is the second term a perfect square? Yes. 2 times 2. And here's the key thing. Is there a minus sign? And yes, there is. Be careful, because sometimes you'll see something like that. You'll see x squared. You'll see like in x squared plus 4. If I had that, that's not going to work. That's not going to factor. Okay, you got to check those signs. So we're left with x plus 2 and x minus 2 when we factor that, and there's really no guesswork. And this is one of the special cases where we can factor a binomial and into two separate binomials. And we're just breaking it down. The other one is a perfect square trinomial, and there's two cases of that, where we have a squared plus 2ab plus b squared equals a plus b squared. And likewise, we have a squared minus 2ab plus b squared gives us a minus b squared. So here we just have a difference in the signs. So if we have a minus sign here and this is a plus sign, this is going to be minus, and if this is plus is plus, this is plus. Notice there is no minus minus, because that doesn't work. Okay, that's not going to work out to be a perfect square. So let's look at that. Let's look at this first example here. Let's say so it was x squared plus 6x plus 9. So how do you know? Well, you know through practice. You start recognizing it the more you do. That's the thing about factoring. It's just one of those things that you have to practice and you get better at. So when I look at this, I say, I notice that this is a perfect square. X squared is a perfect square. I mean, that's x times x. And the last term's a perfect square. That's my b squared term. That's 3 times 3. Well, remember, this term is 2 times a times b. Well, okay, so this is going to be 2, and a, so x squared, the square root of x, to get just a, is x. And then b squared, you square root b to get 3. So 2x times 3 is, well, that's going to be 6x. And it goes through, it works. It passes our little test here. So then I can just go automatically say, that's going to be x plus 3 times x plus 3. And I know it's a plus because both of these are plus signs. But I can shorten that and just say x plus 3 squared. Okay, that's how that works. Now, this one, might take a little bit more practice to get used to. And if worse comes to worse, you can still guess and check and factor this one and get the same results. But a difference of two squares, that one you have to memorize that pattern. So let's try a couple. So I'm going to factor the expressions here. So A, it looks like, first thing I notice is two terms. It's a binomial. So I want to check to see if it's a difference of two squares. First off, is it a difference? Well, yes. There's a minus sign. Is the first term a perfect square? Yes, it is. In fact, it's m times m is 121. a perfect square? Yes, it is. It's 11 times 11. So it meets all those criteria. So then I can just simply say, well, the factors then are going to be m plus 11 times m minus 11. And done. I got it. If I look at b here, I say, okay, I go through the checks. I notice that the first term's a perfect square, r times r, and the last term's a perfect square, 7 times 7. Now, is this 2 times a times b? Well, the square root of 49 is 7. If you double 7, that gives you 14, and then you add in the r, square root of r squared is r, that works out. So then I can just say, oh, well, that's going to be x plus 7 times x plus 7 square, or x plus 7 squared. So, yay. This last one, again, I'm go through the checks. Okay, p squared, that's perfect square, 144, 12 times 12. And then here, is it 2ab? Well, 2 times the square root of 12, that's 24, and then square root of p squared is p, and it checks. But check the signs. Here I have a minus and a plus. That works out. As long as it's not a minus and a minus, we're good. So because it's a minus plus, it's going to be p minus 12 times p minus 12, or p minus 12 squared. And we box that in. I'm trying to actually not cross anything out. Okay, cool. Now let's look at one more thing. Our next example, it's asking, what are the roots of the equation? Okay, a root is a word for solution. Okay, what is a solution to the equation? Would be another way of phrasing it. Or we'll learn later, it's also called the x-intercept. It's also called the zeros. Slightly different things, but referring to the same idea overall. So we're looking for the solutions for x. What that means is we need to figure out, what does x equal? Okay, factoring this helps us. Now notice, this is a key thing. The previous problems, if you look back of them, have no equal sign. Okay, you can't solve those. They're not equations. This has an equal sign. It's an equation. And the first thing we want to do is make sure it's equal to 0. If it's not equal to 0, then make it equal to 0 when you're solving. Okay? So look for the key words. There's a difference between just factoring and solving. So, and I'll point out those differences as we go along here. We'll start off by looking for factors of negative 42, and things that will multiply to negative 42 that will add to be negative 1. Okay, again, we look at the signs. The negative 42, the negative in front of the 42 tells us the signs are different, because a positive and a negative give us a negative. And the negative on the 1 tells us that the larger number is going to be the negative 1, so to speak. And only larger by 1. So that'll help us. These numbers are going to be very close to each other. So we could try, for example, I'm gonna choose one that might be a little bit silly. Let's say I do a negative 21 and 2. Now I know this isn't going to work because these numbers are fairly far apart. And I see, well, I get the negative that I want because negative 21 is larger than 2, again, so to speak. And that's going to give me negative 19, and that's not negative 1. So I need numbers that are closer together. So we could do negative, let's see, negative 7 and positive 6. okay? And we add those together, and hey, that's -1. We have a couple winners. So we're left with x minus 7 times x plus 6. Now, if you were just factoring, if it just says factor, you stop there, okay? But this one we are solving. We're looking for the roots, okay? We want to find what does x equal. So, we're setting this equal to 0. Now, what does this mean? It means when we multiply this first binomial with this second binomial, it equals 0, which means that somehow one of these two has to work out to be 0, because 0 times whatever number is going to be 0. So either the first one or the second one could be 0. So we have to figure out, well, for what value of x could make this equal to 0, and what value of x could make this equal 0. And the easiest way of doing that, now this one's fairly straightforward, but easiest way to do that and show your work is, well, I'm going to set this equal to 0, because this whole thing, if it equals 0, we multiply it with this, the equation equals 0, and the same with this, the x plus 6. So I would solve this and say, oh, well, x equals 7, and on this one, x equals -6. And so thus my solution, because I have multiple answers for x, I'm going to use set notation. X is equal to -6 and 7. And I would box that in. Now that means this is a solution. These are solutions, and we can verify that, because if you substitute either of these numbers in, it will make the equation true, and these would be the only two numbers that would work. So for instance, if I'm going to check this, it would be, I would just substitute in a -6, so I got -6 squared minus -6, using those parentheses around that negative, equals 0. So this is going to give me 36, and this is like saying plus 6, so 6 plus -42 minus 36. Well, 36 minus 36 is equal to 0. Likewise, I could do it with the 7. So 7 squared minus 7 minus 42. Well, 7 squared is 49. -7 minus 42 is -49. And 49 minus 49 is equal to 0. And that checks out. So that's why those are solutions. Anyway, that concludes this first part of factoring quadratics, and we will do part 2 next time. I'll see you on the flip side.